Hello everyone, welcome to this class. So this class will start with physical quantity in physics. So basically the lecture will more on scalar and vector, but for the introduction physical quantity I'm talking about. So what basically is the physical quantity? So you can think of in physics, whatever research or whatever theory is getting postulated or established, a new physical quantity comes into the picture. So physical quantities, as you know, you can say like velocity, acceleration, force, candela means luminous intensity. So these all are physical quantities, which is being dealt in physics. So physics is the science where these quantities are getting dealt with. So how these physical quantities are getting established? So in the entire world, suppose this is the research work is going on in different countries. After the research, when it is completed, the paper is submitted among all. And the outcome is checked. If all are convinced and agreed, then the person who has done the research is proposing a name to that physical quantity. And if that name is accepted by everyone, every physicist and scientist around the world, or the body which is authorized to make the physical quantity name standard in international world, accept it or agree to it, then that physical quantity is named as proposed. So every physical quantity which is being dealt in physics is having unit associated with it. Since it unit is associated means it will have dimension as well. And those physical quantities are measurable, means you can measure it. Like when you're saying 5 meter length. So what you're talking about, 1 meter has been established by the physicist for the study in the physics world. So 5 meter is 5 times that meter. So that 1 meter is standard. And 5 is the magnification of that. Like you are magnifying it by 5 times. So all the physical quantities are measurable. Now, to make the physics study better or easier, these physical quantities has further been divided and given the name like scalar, vector, and tensor. You must have studied earlier in your classes, like in your earlier class 9th and 10th, that scalar is such a physical quantity which has the magnitude but no direction. Direction is not required to describe the scalar quantity. Like in the case of mass, if we say it is some body is 5 kg in mass, 5 kilogram in mass, so it does not require direction to specify it, because it, even if you add the direction to that quantity, it will not have any significance. So scalar quantity is without direction. Vector is a physical quantity with direction. Apart from that, in short, it follows a certain rule of mathematical addition and multiplication. What is this tensor? So tensor basically is a quantity which has physical quantity which has magnitude as well as direction, but it does not obey or follow the mathematical rule of vector. So that is why it is different than vector, though it is having magnitude and direction. We will elaborate about it further. So let us go one by one scalar first. Scalar is a physical quantity, okay, because you know that all the quantity which we are discussing in physics is a physical quantity, right? Associated with physics is physical quantity. So scalar is a physical quantity, that is fine. It has magnitude. Magnitude is basically you are quantifying it. You know the measure of it, measurement, at how much it is. Does not require direction to describe it. So no direction is required to associate with it, with scalar. And it obeys the rules of simple algebra. Simple algebra, like in addition 2 plus 2 is equal to 4, 3 minus 2 is equal to 1, 2 divided by 2 is 1. So it follows that rule. When you are dealing with scalar quantity, you can apply those mathematical operators. The other thing is it can be negative. Scalar can be negative. It does not necessary to be a positive quantity. If we go, for example, like when you talk about electrical charge is positive as well as negative charge. So this is one of the example. There are others as well. But just for your understanding, trying to say that scalar can be negative. It does not necessarily have to be positive. Example of scalars are distance, speed, ampere, volt, coulomb, energy, etc. There are others as well, but these are few which I have mentioned here. You must have been seeing the heading over there, how to get the magnitude of a quantity, whether it is a physical quantity or a number. First of all, you should know how to write when it is say that for a number, write the magnitude. Like when I say you have a number -2. So how to write the magnitude of it? So you will do this, and this is called mod, MOD, mod of -2. And how much it will be equal to? This will be. So basically mod, these two lines, Mod is applied to make a number or quantity positive, and that positive quantity is called the magnitude for the physical quantity or for the number. If you say minus 3 meter per second in mod, the magnitude of this is 3. When it is plus 3 meter per second, if it inside the mod, it will also be 3. Same way, if any quantity, any physical quantity or any number, I am including the number also from the mathematics point of view, but we have to deal with the physical quantity. Suppose A is a physical quantity, and I ask you, okay, what will be the magnitude of it? Means first you will do this mod, then you are not sure that what you should write here. Why? Because you do not know about A. So in your mind, the question will arise. Please let me know whether A is positive or negative. Then only I can get the value of magnitude or mod of A. If A is positive, then mod of A will be straight away A. If I say that A is positive, then immediately you will write this. But if A is negative, less than 0, so then mod of A will become minus A. Why? Because mod of A should be positive, but A in itself is negative. To make a negative number positive, what do? You multiply it with minus 1. This will be your answer. Is magnitude always positive? Yes, magnitude is always positive. Any quantity or any number is being discussed and it is asked that what is the magnitude of that. It should be positive. Come to the next page about your scalar. Scalar does not require direction. Does not require direction. A body is there, like example of mass, 5 kg mass. It does not require direction to specify it. There are two bodies, 5 kg plus 2 kg, or say 5 kg and 2 kg. What is the combined mass of these two? So straight away you will do 5 kg plus 2 kg as per simple algebra. This will be 7 kg. But vector cannot be added like this. This is the difference. That is why it is said vector is having its own mathematical rules. But for a scalar it is fine. One mass is there, 10 kg, because it is of 10 kg. I said 2 kg has been cut and taken off. It was total of 10 kg, 2 kg has been taken off. What will be the remaining mass? 8 kg. With a scalar, you can do simply as you are doing in your simple algebra. Same way when we are talking about speed, speed is a scalar quantity. How do you define a speed? You might have studied that speed is equal to the distance traveled by time to travel that much distance. Distance is a scalar, time is a scalar, speed is a scalar. Suppose you go to school to collect your result. Your school is 2 kilometers away from your home. So you went 2 kilometers, and then after collecting the result, you came back to your home. So 2 kilometers again you came this way. So total distance in this case will be, when you write distance, 2 kilometers plus 2 kilometers. That is 4 kilometers. Suppose in overall this process you have taken 1 hour. So your speed will be total distance 4 kilometers by 1 hour. That is 4 kilometers per hour. So this is your speed. But if you talk about velocity, magnitude of velocity, velocity as per definition is not distance but displacement by time taken to cover that displacement. And what is displacement? You know that displacement is the minimum distance. Suppose a particle is there and then it reaches there. It may have gone this way. It may have gone this way. But its displacement is just join the straight line and make this arrow. So your displacement is the minimum distance between the 2 points. Here, your displacement, because you started from home, came back home. So you reach to the same point. Your displacement is 0. But time taken is 1 hour. The velocity is 0. Okay? Because the speed is a scalar, we got speed as 4 kilometers per hour. But velocity for this circumstance, for this situation, is only 0. Now let us go to the next page. Scalar is obeying the Simple algebra. This is all about scalar. Algebraic rule addition is the mathematical operator. This plus, minus, multiplication, division, these all are called mathematical operator. If this kind of term comes, it does not get surprise. It is basically plus, minus, multiplication, and division. So these are the operators of scalar. And since it is following the algebraic rules, simple addition, as I said, you 2 plus 2 is equal to 4, fine with the scalar. With some unit, of course, because it's a physical quantity. 5 minus 2 is 3. 2 into 2 is 4. So scalar can be mathematically a scalar can be handled like this. 2 divided by 2 is equal to 1. Mass and distance we have already discussed in the last page. So it is the same thing. Basically. It is the same thing. Q square, like okay, one example, so Q multiplication. Q into 2. Q is the charge, right? You are writing the force between two charge Q1 and Q2, 1 by 4 pi epsilon naught divided by square of the distance between them. So straight away you have multiplied Q1 into Q2. But vector you cannot multiply directly. It is having its own set of mathematical rules. It means it follows the vector algebra in a simple way you can understand. So scalar obeys the simple algebraic rule. Now go to the next page. Can be negative. We have discussed on the first page. Electrical charge can be negative, can be negative. We say it is positive charge, Q1 positive, Q2 is negative, Q2 is positive, Q1 is negative charge. Same way potential energy. Potential energy can be negative, can be positive, depending on the reference level from where you are measuring it. Like suppose you have a tower on surface, some object is kept here, and we measure the potential energy from this level. So this is our level from where we are measuring it. So if it goes up, we say that potential energy increasing and it is positive. When it comes down, its potential energy is decreasing, reference to this level, and potential energy is negative while coming down. Work done by expanding or contracting gas. Important to note the sentence. Work done by the gas. They're expanding or contracting. So this is a cylinder, the red part, the red boundary which has been seen. And yellow part is the piston. This is your piston. And this dot circle is gas. So when this gas expands, it does a positive work on piston. So while expanding, the work done by the gas on piston is positive, greater than Q. When it is contracting, so in that case, work done by the gas on piston will be negative. Energy is a scalar quantity. So this is also a kind of example for you. Energy is negative. I'm giving you one more example. Suppose this is your system. One system is there. When you are heating it up with a burner lamp, so you are adding energy to the system. So we can say that from environment, the burner is surrounding for this system. From the environment, the system is getting positive energy. Now reverse the case. This is a system. It is getting cooler now. It is getting cooler now. To become it cool, it is losing the energy to the environment. So in this case, the energy transferred by the surrounding to the system will be negative because your surrounding is not supplying the energy to the system, rather it is receiving the energy from the system. So this is the way it is being dealt with. Okay, let's go to the next phase. Now come to the vector. Physical quantity, fine. This is all the quantity which we are dealing in physics is physical quantity. It has magnitude. Of course, physical quantity must have the magnitude quantified here. It requires direction to describe. Means whenever you are talking about vector quantity, simply telling about the magnitude will not be a correct sentence. You must add direction to it. So when you're talking about speed, speed is a scalar quantity. You say that some particle is moving with 5 km per hour. So speed is okay because it is a scalar, it does not require direction. But when you're talking about velocity and say that velocity of the particle is 5 km per hour and ends your sentence here, it will be wrong. Because velocity is a vector, so you must add direction to it. It is moving with 5 km per hour, but in which direction? That is important to tell. Like if we say a particle is moving with 5 km per hour velocity, you must add that it is going rightward. Then your sentence will be complete. and correct. So now you can say that the particle is moving with 5 kilometer per hour rightward velocity. Going like this, 3 kilometer per hour. Your sentence would be, if you are talking about velocity, the particle is moving with 3 kilometer per hour in the downward direction. This will be the right sentence. You cannot simply say that it has a velocity of 3 kilometer per hour, because velocity we have defined in physics as vector. It has been defined. Same way force. This is your earth. Earth is pulling this object. Earth is exerting a force on this object. Let us say it by F subscript G. Let's say with the 10 Newton. Since the force has been defined as a vector quantity in physics, so you should not say that force on this body is 10 Newton exerted by the earth. You must add the force of 10 Newton is acting on the body towards the center of the earth. Because force is not a scalar quantity. It has been defined as vector in physics. Same way, if some object is lying on a smooth surface, exerting a force F is equal to 5 Newton. So you must say that 5 Newton force is acting on this block in the rightward direction. So then it will be a correct sentence. Because we are talking about force, and force is a vector. So this saying is important. Vector obeys the rules of vector algebra. Means it does not add or subtract like scalar. You cannot make a plus b vector its magnitude as a plus b. This is wrong. It could be a plus b for certain condition, but not always. That is why this will not be always correct, because vector adds in a different way. It is having its own mathematical way of addition. Suppose one vector A is here, another vector, let's say B is here, To add this two vector, you must have studied in ninth or 10th to make the parallelogram or triangle out of it. How do you make the triangle? For triangle, what we do? You bring the head of the vector to the tail of the another vector. And this one is your result of A plus B. This is your resultant vector. So it is not simply A plus B. Its magnitude is different. It is lesser than magnitude of A plus magnitude of B. This case only be true when the two vectors are parallel or in the same direction. This is your A vector. Another vector is B. Since the direction is same, so the resultant of these two vectors will be A plus B. That is the length of A plus length of B. This is A plus B length. So to talk about magnitude, then it is. So this is the case where this applies, otherwise it is wrong always. We will come back in details when we go for the process, mathematical process of vector addition, subtraction, multiplication. For the time being, this much is enough to understand. Same way, does not multiply like scalar, as I gave you the example that f is equal to or electric proportional to q square by r square. Or rather, you should write in detail to avoid confusion. Force between two charge q1 and q2 is directly proportional to q1 into q2 by r square. Since q1 charge is a scalar, you directly multiply it. But you cannot multiply two vector directly like this. It is the vector has its own multiplication method, the type, the rule. So you cannot multiply like this directly. This will be wrong. Like you cannot write A vector, B vector. This is wrong. Vector, two vectors cannot be divided. Like you cannot write A divided by B. Wrong. Vector can be divided by a number or magnitude of another vector or same vector. This one is right. But This one is wrong. Means two vector we cannot divide, but we can divide a vector with the magnitude of another vector or the same vector. This is right. Vector can be negative like a scalar. This depend on which direction you are talking about. Suppose I say that the rightward direction is positive. This is positive for the vector. Like this is the positive direction. Just opposite direction of it will be negative, anti-parallel. These two are parallel but opposite direction. A particle is moving with 5 meter per second towards east. And east if we tell positive. Another particle is moving with 5 meter per second or 3 meter, whichever number you choose, you can choose, towards west. To ride this velocity in the eastward direction, you will have to add minus sign with it. 5 meter per second towards east. So these two are same. What you have done here, it is written 5 meter per second towards west. Same thing, the another boy is saying minus 5 meter per second towards east. Both are correct. So depending on direction, the vector can be positive or negative upon your selection of positive direction or negative direction. Like how do you select the positive direction? If I say this side is the pointer side is positive direction, the opposite of it will be the negative direction. Same way acceleration. Many times you will see that the particle is moving with 10 meter per second in rightward direction. That is positive direction. This direction we have taken as positive. But an acceleration is acting in this direction on that particle with 2 meter per second square. So your acceleration will be, if you write in the positive direction, you must write 2 meter per second square towards this direction. If you write as per the figure which you are saying, you can write, you should write A is equal to 2 meter per second square towards left. But when you make this arrow heading this way, you must add minus 1. Similarly for force, on a block, if we say that this is the positive x-axis direction, so force acting in positive x direction is F1. Force acting in this direction will be towards the negative of the x-axis. F2 will be negative. For writing as a vector for the summation of these two, you will write this F1 plus F. But to see the resultant magnitude, F1 is acting this direction, F2 is in this direction. So we have to add minus sign. So this will be the magnitude towards the positive x-axis. Why towards the positive axis I have written? Because F1 we have taken as positive. F2 is working in the opposite direction, so it will come with minus sign. So this way we can say that vector can be negative. Scalar was also, we have seen that scalar can be negative with an example. Now, since vector is a new quantity, means a different quantity, it is having its own definition. So there must be a way to write the vector in a different way than your scalar. So how to represent or write a vector? How will you write a vector? Vector is associated with direction. So this is the arrow you must have. This is arrow. This arrow is having its head in this direction, its tail in this direction. So we are taking arrow as a sample to show that vector will is in this direction or the other direction. So pictorially, if you see, how will you write a vector pictorially? Suppose you are trying to write a velocity of 50 meter per second on this board. In the this direction, because velocity we are talking about, so we must add the direction also. 50 meter per second. Your direction, this is north, this is east, this is west, this is south. So this one is in the east direction. 50 meter per second, the particle is moving in this direction. So do you think that on your paper or on this board, we can make a picture of 50 meters length? Negative, because this is a small board. Same way your copy, your page is smaller than this. So what do you do? How do you represent a vector on a board? If I want to say that this is 50 meter per second. So we will select a proportionate scale. We will say that 1 centimeter on board, 1 centimeter length on the board is equivalent to 10 meter per second. So this is the scale you have selected. So your centimeter has become 10 meter per second. So 5 division you will have to do 20, 30, 40 and 50. So basically you have selected a proportionate scale, okay, and able to draw that vector on board. So once you have taken this scale, 1 centimeter is equal to 10 meter per second for one particle. So another particle, if it is going in this direction, which is between